Hi everyone, welcome back to Geeks for Geeks practice and welcome back to another problem of the day. So quickly give me a +1 in the chat if my voice is audible to everyone and everything is working fine so that we can start. Hi Vanchika, hi Rishit, hi Hussain and hi Naikaj. So we can take talk about layoffs by the end of this question. Okay. Now let's do one thing. Let's quickly share my screen as well and then we can start off. All right. So I am sharing my screen and I'll change the format. So let's start off with the question without further ado. So the question is nothing but problem of the day, and it's problem of the day for 23rd. The problem name is basically, let me remove the code part. Okay. So basically the problem name is maximum LCM, maximum sum LCM. Now let's quickly see what is the LCM. Like all of you, I can see a lot of people are watching us. So please hit the like button before we start with the problem statement also. Okay. I can see 13, 14 people are live. So quickly hit the like button guys and then we'll start off with the problem as well. If you haven't hit the like button, please hit the like button for the reach of the video and comment a +1 and then I will definitely start off with the problem. Okay. Great. I hope that you will hit the like button and other things will be done by you. Okay. So what is LCM first of all? LCM of two numbers. What is LCM? Like if I talk about what is the, let's say LCM of 2 and 3. What is the LCM of number 2 and 3? Least common multiple of 2 and 3. That is what? I think it is nothing but 6. Correct? Least common multiple of 3 and 2 is nothing but 6, right? The lowest common multiple, like if you will observe, that is nothing but 6. So this is what LCM means. That is if you will think, let's say if you talk about 2 and let's say something like this, let's say we talk about a number, let's say we talk about 6 and 9. What is the LCM of 6 and 9, guys? And anyone can tell me what is the LCM of 6 and 9? You can comment down. It's not that much. Can you quickly tell me, anyone? What's the LCM of 6 and 9? You can comment down in the chat. What you have to do in this particular problem is you'll be given a positive number n. Okay, and you need to write. Okay, yeah, correct, it's 18. It's 18, nothing but 18. Why? Because 6 into 3 is going to be 18 and 9 into 2 is going to be 18. So the least common multiple that is same in both is nothing but 18 here. Okay, that is what LCM is all about, right? So there can be other scenarios as well. Let's say if we have a particular number, right? Let's say we have something like what is the LCM between, let's say, something like 10 and 20? The LCM between 10 and 20 is nothing but what? 20 itself. Correct. The LCM between 10 and 20 is what? 20 itself, right? So a number itself could be the LCM also. It totally depends because you can say that 10 into 2 is nothing but 20 and 20 into 1 is nothing but 20, right? After this, let's come back to this problem. It says that you will be given a positive number n and you need to write a program to find the maximum sum of distinct numbers such that the LCM of all these numbers is equal to n. Okay, so can I say that I can include that particular number? Like, see, if I will see, so if I have this thing, if I have this particular number, right, as the candidate, and if I have this particular number 20, so the LCM of them is going to be what? LCM of these two numbers is nothing but 20 itself. Correct. So basically, what I'm trying to say is, if you have been given the value n, let's say if you have been given something like, let's take a bigger value in this case. Let's say that we take n is equal to something like 25. Yeah, let's take n is equal to 20 only. That will be fine. If I take, let's say, n is equal to 20 now, so I have to consider all those numbers that can make 20, right? Consider it like this. Think of it like this. I should consider all the numbers that can make that can multiply themselves in some way or the other that can make 20, such that they can be equal to 20, right? So if I'll consider 1, right, can I say that 1 can make 20, right? 1 into 20 will be 20, right? After this, can I say that 2 into 10 will be 20? Can I say that 4 into 5 will be 20? Can I say that 5 into 4 will be 20? Right. After this, 6, 7, 8, 9, 10. So 10 and then 20. Is this part clear to everyone? Is there any number that I'm missing? If I'm missing, you can tell me. Right. So 1 and 20 together make a product, you can say. Then these two numbers and then these numbers as well. Right. So what is the LCM of all these numbers, right? All these numbers that I've written, what is the LCM? What is the LCM, guys? The LCM of these numbers is nothing but 20. So if I'm saying that n is equal to 20, So I can have the largest number, let's say is 20. So I want all the numbers that can multiply themselves in such a way that I can get 20. Okay, is the question clear to everyone? Now I want to maximize. So if I want to maximize, like I want all these elements, like let's say this is a b c d, whatever these elements are. So I want as many elements as possible such that my sum is maximum. So in that case, can I say that all these numbers, right? If you'll observe one thing for these numbers, can I say one thing, that all these numbers are nothing but what? Are nothing but factors, right? Of 20. Correct? Is this part clear? Please write yes in the chat, guys. Are you all clear with this particular part in this question? That all these numbers are what? They are nothing but factors of 20. Na? 1, 2, 4, 5, 10. All of them have the capacity to make 20. Right? So if you wanted to make the LCM as 20, you take all these numbers. Right? And this is the maximum number of numbers that you can take. Right? All these are what? Factors, multiples. Right? Can I say that multiple exist in pair? Because if you find that, okay, one of the ways is what? That what I can do is, I can simply say that I can run. Okay, I can run. I can be up and running from 1 till I is lesser or equal to n. Okay, and I can do an I plus plus. I can initially mark my sum, let's say sum variable, as 0. All right, and then I can say that if n modulo I is equal to 0, if the number if I is able to divide the uh, n, right? Let's say n value is 20. So if 1 is able to divide 20, 2 is able to divide. So if n, like if I is a factor of n, then I will add I to sum plus is equal to I. Right, this is what I will do, and ultimately I'll return that in the end. Like when I value is 1, when I value is 2, when I value is 4, when I value is 5, when I value is 10, when I value is 20. Right, so I'll add all this up. Right, so that's nothing but 1 plus 2 plus 4 plus 5 plus 10 plus 20. Right, this is what I can do. That will take order of n time. Right, order of n time. So let's quickly write that up. Okay, let's quickly write that up so that we can get some errors in our code, and then we'll understand what we need to do further. Okay, is this part clear to everyone till this point? So what we need to do here is, we can simply say that the numbers will start from n1, so they will run till n, and I can simply do an I plus plus. Okay, this is what I can do. And then if it happens that the number modulo I, if it's equal to 0, then we can add it to our sum. So we can say that we can take a long sum. Let's take long sum. Let's mark it as 0. And after this part, we'll say that sum plus is equal to I. We'll say that sum plus is equal to I. So if ith number is able to divide n, so that means I is a multiple. And we are considering all the multiples here. Right? We are considering all the multiples here. So in that case, what will happen? We will simply return our sum. Is this part clear, everyone? Till this point, everyone is clear with this part? Quickly let me know. Is it clear, guys? And then we can proceed to the next part. Okay, so see, we are getting the same output. Now let's try and submit this code and see what will happen. Okay, so you can see that we are getting a TLE. Please write TLE in the chat. You can see that we are getting a time limit exceeded error. Please write TLE in the chat. Just quickly write TLE in the chat. We are getting a TLE because if we do it this way, right? If we run a loop for I starting from 1 till I is lesser or equal to n and I plus plus. So we are iterating for all the values from 1 till n, and we are checking and we are adding them. So this is manual kind of task. So it takes order of n time, order of n time. And if you will see the constraints here, so the constraint looks like this. Like let me count the number of zeros: 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the constraint, like basically the n value maximum can go till 10 to the power 9, and in 1 second, assume that you can almost do 10 to the power 8 operations. If you have done a little bit of CP, you know that we can do 10 to the power 8 operations in 1 second. Okay, you can hit the like button if you have understood till now. Okay, so in 1 second you can do 10 to the power 8 operations. So you cannot do 10 to the power 9 operations. So what can we do? Can we do something better? Yes. If you will observe, can I say that I can skip some of the things? What can I skip? So if I have 20 now, so I was considering the number 1, right? If I know that 1 is a factor, like if suppose I is equal to 1, right? If I is equal to 1, if I is a factor of 20, okay, if I is a factor of 20, can I say that 1 into 20 is equal to 20 now, right? If I is a factor of 20, then n by I is also a factor of 20. Like you can say that 20 by 1 is equal to 20. 20 is also a factor of 20. So I'll consider 20 here, right? You might not understand it, with this example, but I'll show you with other value of I. So let's quickly move to the next value. Okay. So then what we'll do is we'll now move to the next value. So I is equal to 2. If 2 is a factor, right? If I is equal to 2 is a factor, so this means that n divided by I is also a factor, because if you see, like, let's say 2 into some value, right, is equal to 20. So this value is what? Let's say, like, this value will be what? Like, this hypothetical value will be nothing but 20 divided by 2, that is nothing but n divided by I, right? So this is going to be nothing but 10 here, right? 10 here. If 2 is a factor, like, if 2 is a factor of 20, then 20 by 2 or 20 by I. If I is a factor of n, then n by I is also a factor. So this will be nothing but 10, right? So that's how we get one more pair. After this, you will see for 3, 3 is not a factor. If you will see for 4, if 4 is a factor, right? So 20 by 4, that is 20 by I. If I is a factor, then n by I is also a factor. That's nothing but 20 by 4. So this will be nothing but 5. Okay, so you can see that we are getting this particular point. Okay, now do we need to go beyond this? Because if after that, when I value will be 5, right? So 4 will be a factor, but do you want to count, like, do you want to consider that? No, you don't want to consider that, right? You want to consider each number exactly once. So can I say that if I go till this particular point, I'll write one with different color. So can I say that if I go till this particular point only, right? If I go till this particular point only, then my task is done. What do you think, guys? Quickly let me know in the chat. Can I say that if I go till this particular point only, then my task is done? Just quickly let me know in the chat. Correct? Everyone is clear with this? You can write a clear in the chat if you're clear with this point. Okay. Right. So till where I'm going, till where I'm going. If you'll observe, like, if you'll observe till where I'm going, I don't know as of now, but if you will see, like, till where I'm going, can you comment down? Quickly comment down till where, till which point I'm going. If n is equal to 20 here, you might not understand it, but let's say that we take another example. Let's say that we take example n is equal to 36, which is a very traditional example. So in this case, if you'll observe 1, 2, okay, 1 will be, like, see, if 1 is a factor, right, then 36 will also be a factor for them. If 2 is a factor, then 18 is a factor, right? After that, if you will see, let's say 3 is a factor, then 12 is also a factor, right? If n is a factor, n by I is also a factor, right? 3 into 12 is nothing but 36. Then if 4 is a factor, right? So I think 9 is also a factor, right? If 6 is a factor, then 6 is also a factor. But will you consider the same number twice? No, because if you'll see here in this question, it says that you need to find the distinct numbers. Now, you will see that maximum sum of distinct numbers, right? So do you want to consider this 6 again? Yes or no? Quickly let me know. No, you don't want to consider the 6s again, right? You want to consider it only one time, right? So you want to consider that if I is equal to 6, so you will add this I also, I. But if I is equal to 6, will you add n by I here? N by, if 36 by 6, it is nothing but 6 again. Will you add the 6 again? Yes or no? No, we will not. So in that case, you need to check that if I is a factor, then you'll simply add I. Sum plus is equal to I. You'll add I to your answer. But if I is not equal to n by I, only then you will add n by I. Because if you will see, if I is equal to 6, then n by I is also equal to 36 by 6 is also equal to 6 in this case, right? So you don't want this. If I is not equal to n by I, in that case only you will add n by I. Is this part clear? Quickly write clear in the chat, everyone. So you will skip this particular point. Is this part clear? That you will add I in, obviously you'll, every time you'll add I to your sum, like, you'll have the ith number, but you will add the n minus ith number only if I is not, like, I is not equal to n by I. Is this part clear to everyone? Right. So till where I'm going, can I say that? Can I say that if I go till this point only? Because if you'll see, if I have 1, then I have 36. If I have 2, then I have 18. If I have 3, then I have 12. If I have 4, then I have 9. If I have 6, right, then I have another 6. So I'm going till this point. Okay. If you will see for 36, what is unique thing about 6? For 36, 6 is what? Under root, square root, right? Square root. To be honest, it's nothing but square root. You are going till under root of n. Okay, you're going till under root of n, like, under root of n. Okay, basically what, like, under root of n. So you can say this thing, here, that you're going till root of n. Now if you will see here, n is equal to 20, so till where are you going? So you will say that, okay, again, under root of 20, under root of 20 is what, 4 point something. So you're going till here now, like, you are going till this particular point, right? Till the decimal value, like, till the nearest integer value. 36 is a whole square. Obviously, yes, Rishit. If this much part is clear, all of you can hit the like button, and then I'll proceed further. I'll first of all code it, and I'll show you one thing. Like, see, we are going till square root. So, what will we do? We will simply say that, okay, we will initially mark our sum value as 0, and then we'll start our iteration from 1, and you can say that I is lesser equal to square root of n. Okay, then I'll come to the most optimized part also. I is lesser equal to square root of n, then we can do I plus plus. When you're considering integers, this will be integer only, so don't worry, because we are comparing it like that. So it will be compared for the integer part only, and the fraction part can be neglected obviously. When I value, let's say it is 4 point something, right? So when your I will reach 5, so it will obviously be skipped. So you will do what? You will say that, okay, some like, if it happens, right, if it happens that n mod I is equal to 0, so if I is a factor, then you will do what? You'll say that, okay, sum plus is equal to I. That is what you're going to do for sure. uh, but if it happens that n by I is not equal to I, okay, if n by I, if this particular value, that is nothing but n by I, if it's not equal to I, then in that case you will say that sum plus is equal to n by I also. You'll add n by I also. You can write ni in the chat. You'll add n by I also in this part, and then in the end you will return the sum. This is one of the ways, right? So in this particular part, what you can say is like this particular thing. Obviously, what you can do is you can run I till lesser equal to square root of n. Okay, instead of running it till there. Now, if n is a factor, then you need to add it, and you'll say that if n by I is not equal to I, in that case you will add I also. So you'll say that, okay, sum plus is equal to nothing but I as well. Right, this is what you can do. And let's try and compile this code now and see what will happen here. Okay, we are getting a wrong answer. Why? Are we doing something wrong? I is lesser equal to this particular point. I is lesser than ni plus plus. If n by I, okay, so if I is a factor, then I'm adding. Okay, yeah, I need to add n by I. Sorry, guys, I need to add n by I. Sum plus is equal to n by I. Sorry, it should be n by I. Yeah, now it should be fine. Okay, works fine. Let's try and submit it also. Okay, so this part is clear, right? Now there's another way of writing this thing. See, what you can do is now, if you talk about, let's say, something like 20 now. So when your I value is 1 now, you can also check it in this condition. Instead of writing this will take a lot of time complexity. You can do what? Like if you write I is equal to less than equal to square root of n, right? So see, basically I'm saying that you are saying that I, and you are saying here square under root of n. To be honest, square root of n is what? Under root of n, you can say. You're considering I under root of n. If you multiply both the sides by square, let's say for a second, so this will be nothing but I square, okay, I square and n. So basically what you can say is, you can also say it like I into I is lesser equal to n. And this is much better because here you have removed the concept of doing this particular thing. Okay, you have removed the concept of square root. Okay, you have removed the concept of square root here because this has a certain time complexity. Na? Logarithmic of n. In the best case, you can say it will have logarithmic of n time to calculate the square root value. Then obviously, see, the overall time complexity will be square root of n only. Why? Because you can get the square root of n in log n time. That is fine, but you have to iterate till the under root of n. From 1 till under root of n, you have to iterate in any case. So that is why it will take time. And if you are doing this on on some platforms, let's say code forces or something, in that case it is better to do it like this: I into I is lesser equal to n, because this will be order of one complexity. Like basically you're checking multiplication is just constant time, right? So in this way, if you will check, so this is the best way, because if you calculate square root normally, so it will take root n time, right, to calculate the square root. If you calculate square root using the other way, that will take logarithmic of n. But in this way, you just eliminate the square root calculation part. So this is nothing but order of one operation, because always you always have to go till under root of n. From 1 till under root of n you have to go, so the loop will always be up and running, right? So you will say I into I is lesser equal to n. Is that clear? Because you can consider I under root of n. You multiply both the sides by you basically multiply, right, I cross I, and like I into I and under root of n into under root of n. So it will be nothing but I square, and this will be n, right? So you can do what here in this particular portion. If I'll open it, so what we can do is we can simply say that I into I is lesser equal to n. This is also what you can take. Why? Because if you will see, let's say if you have I is equal to 20, sorry, if you have n is equal to 20, right? So you can say that when I is equal to 1, right? So I into I is less than equal to 20, right? So you will say that, okay, that's fine, because when I is equal to 1, then you'll get 20. Then when I will become 2, then what will happen? When I will become 2, in that case, you'll say that 2 into 2, 4. 4 is lesser than equal to 20. So you'll say that, okay, now I'll get 10 as well. Then when I value will be equal to what? 1, 2, then 3, then let's say 4. Okay, when I value is 4, then 4 into 4 is 16, which is less than equal to 20. So you'll get the value 5 also along with it, right? Then after that, when I value will be 5, let's say, then 5 into 5 is what? Suppose that I is equal to 5. For I is equal to 5, 5 into 5 is what? Greater than 20. In that case, you will do what? In that case, you will skip this particular value, right? So basically, when I will be 5, then you will, then I into I will be 25. So it will be greater than this 20. It will not be lesser equal to. So that is when you will skip. Is this part clear to everyone? Let's quickly try and submit this code. If everyone is clear till this point, please hit the like button, guys, and then I will think that, okay, you've understood everything. Has everyone understood everything till now? If you'll submit this code now, so I hope that it will get accepted as well. Okay, so you can see that I am able to get the solution, right? So it passes all the test cases that were given. Is this question clear to everyone, guys? Quickly let me know. Okay, Braham Gaur is saying that it's clear. What about other people? Other people are also clear with this question. It was a kind of easy question only, where basically if you have been given a particular n value, right, and you want the LCM of everybody to be 20 now, so you will and you want to take the maximum numbers. So obviously with the help of 1 you can make 20, with the help of 2 you can make 20, with the help of 4 you can make 20, with the help of 5 you can make 20, with the help of 10 you can make 20, with the help of 20 you can make 20. So all these numbers will have the LCM as nothing but 20, and all these numbers are nothing but factors. So indirectly you need to find the factors, and in under root of n time you can say, you can have all the factors, and you can simply do this thing. Okay, yeah, you can also do this thing if the constraints are tight, then you can do it. But Rishit, here it is not long. The n value is given as int. Okay, Rishit, here the n value is given as int, so that is why I don't think that it will overflow, no? Because integer max is a higher value, so it will not overflow. If it was given as long, then you could have done n by I also here. Is this part clear? Others are also clear with this particular part. Quickly let me know, guys. Is everyone clear with it? The question is clear, absolutely inside out. Basically, you find this, like you take a variable for sum, then you iterate from I till under root of n. You can say basically I into I is less than equal to n is nothing but under root of n only. And then if I is a factor, then you simply count I, simply add I to your answer. And then if n by I is not equal to I, in that case, sum plus is equal to n by I, right? So if I is a factor, then n by I is also a factor, and if it's not the same as I, then you'll add it to your answer, and simply in the end you're simply returning your answer. Overall this approach will take square root of n time. Okay, layoff. If see, this is the best time, like I'll say that this is the best time to prepare. Okay, all that matters is the skills, right? Skills means DSA, like you can say DSA skills. This is I'm Nikaj, I'm considering you for this answer. So skills, DSA, like basically in terms of skills you can say DSA, development skills, any kind of development. And then the subjects, the CS core fundamentals. If you are able to understand all these things properly inside out, then you will not be fired from anywhere, or you can say that you'll get a job easily. So I don't think that you should consider much of the layoffs if you're currently in college. So these are just news that these things happen time and again, after certain years, so you cannot do much with that. But if you are skillful enough, then there's nothing that can stop you from getting a good job. Okay, so I hope that this answers, but make sure to practice this problem. I'll quickly provide you the link of this particular code as well, so that others who are beginners, they can get this thing. Yeah, you are in first sem, so no worries. You can chill out a little bit. Okay. So others are clear with this. So, but sir, it's recession after all. Yes, but you can only prepare now. You cannot do anything about recession. Uh, it's better that you prepare yourself for better opportunities. Okay, so I've given you the code link and talking about the today's problem. So if you will search GFG POD, so you will get the next link. I have done this question on my own. Great, Naikaj. So the next question is longest biotonic subsequence. So tomorrow I think Siddharth is going to take this particular problem. So make sure to practice it. It has been asked in Microsoft and Cisco. So make sure to practice this particular problem as well, and then come to the editorial part tomorrow. Okay. So did you understood everything, guys? Quickly give me a plus one in the chat if you have understood everything till now in this particular question, and then we'll end the stream as well. And hit the like button if you haven't hit till now. How to crack GFG? For cracking GFG, you should be good in DSA, and then you can apply on GFG careers portal, or you can message someone who's working full time in GFG, and then you will be good to go for GFG. For any role that you are considering DSA or development or any role. Okay, so this was it for today, guys. I think the problem of the day for the last Friday, like that is for Friday, that is going to be interesting. So let's see that if you have understood this problem till the end. So make sure that after this video is over, after the live stream is over, so after the video gets over, make sure to comment down understood in the chat as well, like understood in the comment section as well. And thanks a lot for watching. Till then, good night, take care, and keep coding. And I'll see you in another live stream. Good night, everyone. Keep coding, guys. Bye. Take care.